Computer's fine. All right, so let's do example 3. Example 1 and 2 is more conceptual, so I'll let you read those ideas later, and we'll talk about it as we go as well. So the big thing they want you to know is what's the difference between sample and population. For example, if you sample college students, right, that's a small set compared to asking everyone in the city, right? So if you ask everyone in the city about a question about the city, that's more of a population. If you ask people in random neighborhoods, that's more of a sample, okay? But anyway, I'll let you look at that later. So let's focus on this idea of frequency. So we're still kind of in statistics type of section. So for the first week of November, Juanita received the following scale 1 through 5 from her customers. So these are rating cards. They were rating her, maybe it's a restaurant or something. I don't know what it is. She has customer data. So let's go in order, right? So how many times did the 1 appear? Here's 1. It's 1 time, right? We count them all up. Now count the 2s. I don't see any 2s. All right. 3. There's 1, 2, 3, 4, 5. So 3 has a frequency of 5. So all frequency means is how many times did that specific category appear. Okay, so it could be a range of values, or it could be like category or color, whatever. Depends on what data we're talking about. So now 4 appeared 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Five appeared 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay. So that's how you create a frequency distribution, okay? So in a little bit, they'll ask us, that's what we did right here. So we organize the data into a frequency distribution. We can do a bunch of stuff with this, but for now, that's how you make it. No big deal, right? Okay, the next one. Here they want us to find a range of values. So how many appear 15 through 19? So they want us to do a tally. In the homework, they might make you do that too. So 15 through 19. There's a 19. Is that it? So 1, 2, 3. I don't see anything else. So the frequency would be 3, right? 20 through 24. 1, 2, 3, 4, 5, 6. Oops, missed one. 7. I believe that's all of them, right? Seven. So these are called class intervals. Instead of a category, we have an interval. So that's all you would do. You would organize the data and just keep counting. I'm not going to do all of them because there's other things we need to do. So that's the idea. Over here, though, they actually apply the information. Okay. So let's do this one instead. So let me maximize this for myself. So how many people got an A? Okay. 1, 2, 7, 8. So we have 8. I'm not gonna count. I'm not gonna do a little tally just because it's annoying. How many B's? 1, 2, 3, 4, 5. How many C's? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, how many D's? Well, that'd be 1. Oh, I'm missing 85 there. This should be. This should be 6. Okay, so 1 D, 2 D's, 3, 4. Looks like I missed a C. And there's only one F, right? Nope, 2. So using this information, the frequency will be the height of the histogram. Okay. One moment. All right, so a histogram is just basically kind of like a bar chart, but not exactly. So both histograms and bar charts provide a visual display using columns, and most tend to get kind of misrepresented. I feel like we can't tell the difference. But a histogram represents frequency, so that's the big difference. Okay. Let me see if I can find a picture. So here we go. So let me just put one up for you. That might be easier. No. Okay. So here's the histogram. So notice how the frequency of these examples right here, these values, right, are measured here. So anything between 0 and 50 will have different heights. So these could represent stuff like, let me see, what's a good one? Simple. Oh, here we go. So anything within negative 0.5 to 0.49, it's going to have 180. So if we go to that area, it's above 150. So each category, so A, B, C, D, E, F in our example, will just have appropriate heights. That's all it is. So in our example, which I think I already lost the numbers accidentally, you'll just have some number for the A, then one for the B, C, stuff like that. Oops. So that's all you would do. That's all a histogram is. The height is based off the frequency. So this right here is the height. Okay. Anyway, so that's how you create a histogram. You find the frequency for each category, and then you make that bar chart. That's it. Okay. So a frequency polygon, basically, let me give you a picture. So frequency polygon is basically going from the tops of the histogram. You see this picture right here? That's a video. So as you can see, you start at the lowest point of the first category, then you go to the next category. So every peak of every category is where the line's going to go. And that's going to be your polygon. So just draw it over the bar chart. If you have no bar chart, just graph the highest height of each frequency. Okay. So in our example, we would have some number for I don't remember how many we had for A, but it'd be something like, say, 6, and then we'd have B's we had this many, C's we had that many, D's we had less, S we had less. So just create a polygon graph like that. Nothing crazy. Oops. Okay. Any questions so far on what a histogram is or a frequency polygon and what the heights are? All right. Let's move on to stem and leaf. So this is a pretty simple concept. So a stem and leaf is you pick a number value, like the tens place value, and then the number to the right will be the leaves. So basically you look at all the 50s, right? So this 5 represents 50. So look at the lowest 50. We got one there. What else? I think that's it, right? I don't see any other 50s. Oh, wait, there's one. Okay, thanks. So there's a 0 and there's a 1. So the 0 represents 50. So this is the leaf. The stem is the 5. See that? 5, 0, 5, 1. So that's how you create a stem and leaf. So let's do the 60. So 60, the lowest one will be, so there's a 3 there, 2, 8, 5. I think that's it, right? Should be 4. Double check. So 2, 3, 5, 8. So each of these numbers represents one of these data points. 62 is represented by the number 2. 63 is represented by this number here. Does that make sense? So that's all you do. You just keep going along the way. So on the homework, just go least to greatest. And that's all you got to do. All right, so we'll move on to something else if you guys are good. So that's stem and leaf. So the next part of statistics, chapter 9, is trying to understand what how data and graphs can be used to trick us or to lie to us. That's a big deal because people will quote like studies and numbers and whatever, but if you don't know what they mean, they can make you think that all kinds of stuff is true, especially nowadays with all this fake news stuff, right? So you need to be, you know, more careful whenever you see a chart. Like I'm sure you guys have seen like pictures with some text on it on the internet and people think it's true. I'm like, dude, it's just a photo with some guy writing words on it. Like it's not a fact. But it can also be done with charts. So you might see a chart and be like, oh, okay, that looks interesting. Well, that sounds legit, but it could be complete BS. So if you look at example 7, they're trying to show us that there's been a lot of inflation since 1960 all the way to 2010, right? This is the price of a chocolate bar. So determine how this is misleading us. Can you tell how it, or can you think of how this graph might be lying to us or trying to mislead at least? The first thing I see for number 7, I mean, this is kind of hard. I don't see it right away, but notice on number 8, they tell us where the data came from. This doesn't tell us who made it. Like, why should I trust this? Like, it doesn't say this was created with data from the Census Bureau or this was created by a study done by Hershey. It doesn't say anything. So I'm like, I'm not going to believe this, even if it's true, without some sort of what's the word? The author or something. Okay. Now, also some things you should keep an eye on is look at the axes. So for example, if they only would have shown us, if they would have just shown us these last few years, like 2000 and 2020, we would have noticed that the chocolate bar hasn't changed much. It went from 80 cents to $1. Like in 10, 20 years, I don't really care. But looking at a long stretch of time, it looks insane. But I'm like, well, that's just how basic economics works. Every year there's inflation, no matter what. Some years are higher than others. Who cares? So maybe it's important, maybe it's not. Look at example 8. US population 1950 to present. Okay, so it's showing, so they're using the size of this little dude here to represent the size of our population. But look at the numbers, right? 1950, you got 152 million living here in the US. 2010, we had 310. So that's about double, right? But this guy isn't, or these two, right? If you look at the little monitos there, this guy is more than twice the size than this guy. So this is misleading. So it makes me think that, wow, we have this huge increase, but in reality, it only doubled. This looks like triple the size or something. It's big. This one looks like double almost, or maybe this one size-wise, but in reality, the numbers is what matters. The pixels are just trying to distract us. So keep that in mind whenever you look at a chart. Okay, so that's pretty much it for 9.1. Okay. 9.2 is measures of central tendency. So this is when we calculate mean, median, that type of stuff, which can be done on your calculator. So let's get our calculators out. Let me see if I can grab one here. Actually, give me a 1 minute. I'm gonna go get one from my office. I don't have one on me. One. So on the workbook, page 108. Go ahead and just copy paste these words. To the chat box, you can see it. Okay. So the length of time of 5 different customer service calls are below. So they give me a list. Find the mean and median. Okay. So before we start doing it, you must know, let me give you the, go ahead and give you the formula. Now, mean is equal to, as also called the average X bar. So it's written like this. So the total number of elements, n, over the sum of all the numbers. So this would be simply 1, 2, 3, 4, 5. So you total of 5 things. You add them all up. That would go on top, right? The sum. 3.4 plus 9.7. Whatever. Now, let me show you how to do it on the calculator. So the numbers were so what you can do is hit data. And notice here I have a list of stuff. So I would just say, just keep hitting, just delete the entire list. I believe you can clear it somewhere. Let me see. Thought. Oh, I'll just delete one by one. Okay. So there's an empty list. So just put in 9.7, enter. Oops, 3.4 was the first one, but who cares? The order is not important. 4.2, 97, 34, 42, 1.6, 1.8. Okay, so once it's in there, just hit quit. So now go to second and see where it says stat above data. You have one variable statistics, two variable statistics. So just pick the first one. Then you're going to tell it to do L1. Frequency 1, because we're not doing any frequency at the moment. So check it out. So there's our average, X bar, 4.1. There's the sample variance, I'm sorry, standard deviation, population standard deviation, the sum of all the values, the sum squared, the minimum value, the inner first quartile, and the median. So it only asks for two things, right? Median, 3.4. So I'm gonna write that down. The mean is, what was it again? X bar, 4.14. And the median is 3.4. So that's all you got to do. Just punch it in here and it shouldn't be too bad. Okay, so number 2, find the mean and median. So you'll do the same, plug in these numbers, and calculate one variable statistics. Okay. Now mode is the value that appears in the most number of times. Okay, so look at number 4. 9.3, 9.3. Now it appears 3 times, everything else appears once, so the mode of this question would be 9.3. Right, oops. It's the ugliest 9 I've ever written. There we go. The mode of this guy would be, looks like 11. Oh, actually 4 appears 3 times. Sometimes you can have 2 modes. This is called a bimodal. So the answer is 11 and 4 because they both appear the same number of times. This one has no mode. Unless you want to think of it as every single one is a mode, but that's silly. But yeah, that's all mode means. The data point that appears the most number of times in your list. So example 6, find the mid-range. Here it says find the mean, median, and mode. So those the first two is done by the calculator. Mode we got to do ourselves. Do you see anything that repeats for the mode? Okay. Yeah, it looks like there's no mode. Mean and median, you just plug these into the calculator and you should get the answer. Mid-range. We haven't talked about mid-range. I believe that is the biggest value minus the smallest value, but let's double check. Mid-range formula. So you add the smallest and the biggest, divide by 2. Okay, that's not that bad. So we'll use this guy for question. So the biggest value here is 630, right? No, $9. $9 plus the smallest, 72 cents. So that number will be your mid-range. So this is mid-range. Anyway, any questions on finding mid-range, mean, median, or mode? Is that clear? All right, let's punch in the calculator one more time, just in case. I copy it over here, that way I can see it. So go to data, clear the list by hitting delete a bunch of times. Enter 6.3, the first one, 1.75, 4.26, 630, $9, 0.72, 1.1. So hit data, one variable stats. Oops, crap. Okay. So the answer for the average is 3.85. So there's the mean. The mean is 3.855. Then it said median, right? $3.05. Okay. And the mid-range is $9 plus 0.75 divided by 2. Okay, that's pretty much it. So those are the answers for number 7. There is no mode. Sorry. Okay. Number 8, it wants to know the main median of the thickness of boards. It's the same stuff we already did. Calculating GPA. Okay, well, it looks like it could be interesting. They got number correct. So she got 2 different A's, right? She got 2 B's. She got a C. Oh, wait. She's 4 credit hours where she got 1 of these. Okay. She got a B at 2 credit hours, a C at 3 credit hours. So it's the same stuff as above. They want to know the total points. Well, you guys know what the A is worth on your GPA. Right, the A is actually worth 4 points. But B is worth 3 points. C is worth 2 points, 3 and 4. Okay. So the total points for that class you took, that was 4 credit hours, is going to be 16 points. This is worth 6 points. 2 times 3. 3 times 2, 6 points. Alrighty. 9 points and 4 points. So the number of credit hours she took is 4, 6, 9, 10, 13 total, right? Total points would be, let's see here, 10, 36. Oh, just add them. It's 41 points. Okay. So her GPA should be, that's the worst G I've ever written. Oh, dang it. G. It's going to be the total points divided by the number of credits she got. I'm getting a 3.07. So she has about a 3.07. I guess 8. check. Calculating GPA. Already. I don't want to automate it. Automate it, do it. So how do you do it? Yeah, that's what we did. We took our grades times the credits that we earn divided by credit. So let's go over it one more time in detail. An A is worth 4.0, B is 3.0, etc. So you multiply each of these times the credit hours of the course. So if you have a long course that's 4 hours long, right? Like it has a lab or something, that's going to weigh more. So if you get an A in that class, that will boost your score more than getting an A in like a basic 1 hour class. Okay. So look at this guy here. Right here, pre-cal is 2 hours, history is 2, chemistry is 4. So the chemistry weighs a lot more. So the PE, the fact that I got a C in PE, I'm like, it doesn't really hurt my overall because it's only 1 hour. I mean, it still sucks, but the A in chemistry is gonna outweigh it big time. So I should have a decent GPA, but if you get an F on a 4 hour class, then that's gonna be hard to overcome. Or most likely we'll have to redo it. Otherwise it's gonna be a big deal, right? So, but anyway, that's how it works. You multiply the credits times what it's worth, you add it up and you divide by the total hours, total credits, that's all. Okay. Let's look at the homework. So we are on 9.2. Okay. So the first few questions, they're just gonna ask you, find the average, right? You can use the calculator function I showed you, or you can do it old school, add them all up, divide by the total number. Now, when they ask for frequency mean, this one's a little different. So there is a long formula for this, but I'm going to show you how to do it on your calculator. So let me see if I can. 1, 2, 3. So the first one is 1 through 8. So I'll come back to that in a second. Okay. Sounded earlier. Where'd it go? Okay, so this is what you're going to do. Clear the first one. So on the first list, put 1, 2, 3, 4, 5, 6, 7, 8. On the next list, put the other frequency part. So on your calculator, put in for the next list 1, 3, 6, 6, 5, 3, 1. Son of a. Start that over. 1, 3, 6, 6, 5, 3, 1, 2. Okay. So I put both lists in here. So now what I want you to do is hit second stat. So you're going to do you're going to do one variable stat, but you're going to have a frequency now, right? So press L2 to be the frequency. That's where the, if you remember the homework question, right? Let's, before I press enter. See how the second row is the F? So and I made L2 this one, so make sure that is your L2. Calculate. So this will actually give me a frequency mean, so we don't have to do it the hard way. So this is the easiest way to do frequency mean. So 4.259. Okay. 4.259. Cool. So I recommend doing it that way. Median, we've already talked about, is for basic lists of values. Frequency again, do it the exact same way, but scroll down to median. Mode, let's just find the one that repeats the most. Okay. Mode for frequency, though, is just going to be the one with the highest frequency. So number 1 would be, right, this one would be the highest one. Okay. But that's pretty much it for 9.1 and 9.2. There's a polygon that you have to graph yourself. This is the leave question we talked about. Any questions on this? Does 9.1 and 9.2 make sense? Right, well, we will stop here and I'll upload this soon. Actually, I'll probably do 30 minutes or so. I'll see you guys Monday or Tuesday.